Welcome, ladies and gentlemen, to another IG Maths live lesson. This is part 8 of our second exam preparation series. Okay, so we're going to pick up where we left off last week, and that was, I think, question 6, and it was D. So 6D, we were asked to complete the square, or actually just to give this quadratic expression in the form q minus 2x plus p squared. Okay, so basically we completed the square. And remember, if you want to use this formula, it has to be in the form x squared plus bx plus c. Okay, and this was a unique case in that we did have a coefficient in front of x squared. Okay, so if you have a case like this, remember to either factorize the minus 2 or divide by it if it's an equation. Okay, this is an expression. So that's why we factorized the minus 2, and then we applied the formula for whatever is left. Okay, so that was the previous question, and we determined that my turning point, or actually just the value of p and q, is minus 3 and 23. Okay, so then for this next question, we have to write down the coordinates of the maximum point of this curve. Okay, so this curve is actually the exact same expression in the previous question. So how do we find a turning point or a maximum or minimum point of any quadratic graph? Okay, so we can just look at the completed square form, and whatever is inside this bracket, the opposite sign will be my x value for the maximum point, and then we can just write this value for q as is for my y coordinates. Okay, so in this case, we can just say x minus 3 is equal to 0, and therefore x is equal to 3. Okay, so this is my x coordinates. So this is the long way around. The short way around is just to say that it's the opposite sign of whatever is inside here, and x is just equal to 3. Okay, so just a quick shorthand way of doing it. And then for q, or my y value, that is just 23. Okay, so we have 3 and 23. An easy mark over there. Okay, moving on. Let's see. Okay, E. The energy of a moving object is directly proportional to the square of its speed. Okay, so this is proportionality or variation. And the speed of the object is increased by 30%. Calculate the percentage increase in the energy of the object. Okay, so let's just quickly say that E is directly proportional to s squared. Okay, so where did I get this? I just said energy is directly proportional to speed squared. Okay, so they say that it's directly proportional to the square of its speed. Okay, great. So now we have a proportionality equation going on here. Now we have to add a constant. Now for this specific example, the constant isn't really important because we're just going to work with an increasing factor. Okay, so E is equal to k s squared. Now there's a reason why I'm doing this, because what I'm going to do now is I'm going to increase the speed by 30% and then see what happens to the energy. Okay, so let's see. So if we increase the speed by 30%, remember, if you increase with a certain percentage, you can just add that to 100 over 100. So that's 100 over 100 plus 30%. Or you can just say that it's a multiplier of 1.3. Okay, so I'm going to go with percentages. So I'll say that this is 130 over 100 because it's 130%, okay, of my original speed. So we have k times 130 over 100, and then s is just still squared. Okay, so this is s times, all right. So we have s squared. Okay, so if we simplify this, let's see what happens. We will have E is equal to k times, now 130 squared is just 130 times 130, and that is 169, or actually 16,900. Okay, so here we have 16,900 divided by, and then 100 squared is just 10,000. Okay, so two of these zeros can cancel, and this is just s squared. Okay, so it's already looking promising. We can cancel some zeros. Okay, so now we have 169 over 100. So E is equal to, let's see, k times 169 over 100 times s squared. Okay, so this essentially means that my energy will increase by 69%. Okay, so if its speed is increased by 30%, then the energy will increase by 69%. Okay, and I can say that because if we just simplify this to a percentage, remember anything over 100 is just a percentage. So then this is 169% times this constant times s squared. Okay, which means that my energy increases by 69%. Okay, and that's my final answer, 69%. There we go. Any questions? And we are moving on. Okay, question 7, a bit of mensuration. Let's see. Okay, the diagram shows a container for storing grain. The container is made from a hemisphere. Okay, hemisphere is also half a sphere. Okay, I'll always write this just so that you can apply it to the equation for the volume. Okay, and a cylinder and a cone. Okay, so here's my cylinder and below here's my cone, each with radius of 2 meters. Okay, so that's the radius also of the hemisphere, the cylinder, and the cone. The height of the cylinder is 5.2 meters, and the height of the cone is h meters. Okay, so this is a variable. We do not know what this height is. Okay, so for the first question, calculate the volume of the hemisphere. Okay, so if you don't know what the volume or the formula for volume of a hemisphere is, they usually give the equation, not the equation, the formula for the volume of a sphere. Now you have to realize that a hemisphere is just half a sphere. So we're going to take this, this formula and just divide it by 2 to give us the volume of the hemisphere. Okay, so to find this volume, let's say V is equal to, so it's going to be half times 4/3 pi times r cubed. Now this radius is just going to be 2 meters, so we can just say that this is 2 cubed, and we can simplify. So we need to give our answers as a multiple of pi. Okay, so be careful with your questions. They sometimes ask you to give it in terms of another accuracy. Okay, and now we have to give it as a multiple of pi, so we're just going to simplify. Okay, so if we multiply this half of this fraction, we will have 4/6 pi, and then 2 cubed is just 8. Okay, so what is 4 times 8? We can just simplify there. So 4 times 8 is 32. And we have 32 divided by 6 pi. Okay, and we can simplify this. We can just divide by 2 so that this will be over 3. So this is 16/3 pi. And that is my final answer. Okay, so I'm happy with that. Let's move on to the next question. Okay, so now the total volume of the container is 88 pi/3 meters cubed. Calculate the value of h. Okay, so we need to calculate the height of this cone. Now they give me the total volume of this entire container, and we don't know what this height is. So I'm going to start off by saying that my total volume, so let's just say V total, is equal to volume 1 plus volume 2 plus volume 3. Okay, and these 3 being 1, 2, and 3. Okay, so we have these 3 different shapes. Okay, and let's think about the formulas for all 3 of these. So we know that the volume of the hemisphere is just 16/3 pi. We've already calculated that. Okay, and the volume for a cylinder would just be the area of the circle times the height or the length. Now, in this case, it's height. Okay, so we can very easily do that. And then they give us the volume of a cone, which is just 1/3 pi r squared times h. Okay, so we can get all 3 of these volumes, and then the variable is going to be in the formula for the cone. Okay, so let's just substitute and see what we come up with. So for the first volume, this is going to be my cone. We can say this is 1/3 pi, and the radius is just 2 meters. Remember, all 3 of them have a radius of 2. So this is 2 squared times h. Okay, h is a variable. This is what we will be after. Okay, we will be solving for that. And let's also just put this total volume in here. So 88 pi/3, and then plus, so this volume is going to be for my cylinder. So that's just going to be pi r squared. So pi times 2 squared, or the area of my cross section. And so it's pi r squared times that height. I think that height was 5.2. Yes, okay, so there's 5.2 over there. So we multiply 5.2. And then plus the volume of my hemisphere, so plus 16 over 3 pi. Okay, so we don't need to give our answer in terms of pi, so we can actually use our calculator to help us a bit for this question. Okay, but let's just simplify it a little bit. So we have 88 pi over 3. We'll leave this as is, and then this would be 4 over 3 pi h. Okay, just because this 2 squared is a 4, and we can multiply the two numbers. Okay, so we have 4 over 3 pi times h, and then plus, so this is 4 times 5.2. So let's put that into our calculator. So I think that's 20.8, but let's just make sure. Okay, always double check. So this is 20.8 pi, and then plus 16 over 3. I don't think I'm going to simplify that even, because that's going to be 5.3 recurring. Okay, so I'm going to leave this as a fraction. So 16 over 3. Okay, and now it's just a linear equation. We can solve for h. Okay, so get all of our numbers to the one side, and then we'll divide by 4 over 3 pi, or just multiply by 3 over 4, and then divide by pi. Okay, awesome. Also, just something very quickly, if you see that there's a term straight throughout the equation, okay, and I almost forgot about this pi, you can already cancel that term. Okay, so because pi is present in every single term of this equation, we can cancel it out because we are effectively dividing by pi straight through. Okay, so if I do that, and then I'm going to rearrange a bit. So now we have 88 over 3. Okay, and I'm going to throw this 20.8 to the other side, so minus 20.8. And then also I'm throwing this 16 over 3 over to the other side, so it's minus 16 over 3. And this is equal to, let's see, 4 over 3h. Okay, so now I'm going to put this into my calculator, and then I'm just going to multiply that by 3 over 4 to get rid of this fraction. Okay, so that we can cancel out like that. And then I have to do the same on the other side, and that will give me my answer. Okay, so h is equal to, let's see, calculated time. We have 88 over 3 minus 20.8 minus 16 over 3. And let's see, that is equal to 16 over 5. And then we multiply by 3 over 4. Okay, so h is equal to 2.4. And what's my unit for this? This would be meters. Okay, so that is the height of the cone, 2.4 meters. All right, so not too bad of a question, just a normal linear equation that we very easily solve. All right, moving on to the next question. Let's see. Okay, so now the container is full of grain. Grain is removed from the container at a rate of 35,000 kilograms per hour. Okay, so 1 cubic meters of grain has a mass of 620 kilograms. Okay, so knowing this, we can calculate the total mass of this container with grain, right? Because we have the total volume of the container. So if we want the total mass, we just multiply that with the 620 kilograms. Okay, so we need to calculate the time taken to empty the container. Give your answer in hours and minutes. Okay, so relatively simple. We're just going to calculate the total mass. And once we know what the total mass is, we can just divide that by this rate of 35,000 kilograms per hour. Okay, and that will give me an answer in terms of hours for how long it takes to empty. Okay, so this total mass is equal to, so what was my volume again? My total volume of the container was 88 over 3 pi, or 88 pi over 3, same thing. So 88 pi over 3 multiplied by 620 kilograms. Okay, so let's see. Total mass, I'm putting this into my calculator, and I'm going to use this exact answer when doing my next calculation. Okay, so please remember not to round in between your steps. Yes, we can round by writing down a rounded answer, but in our final calculation, we use the exact calculator answer. Okay, please do not forget that. Okay, so this is 57,135.09839. Okay, and I'm even writing down the accurate answer. Okay, so now to find the time taken. So we can just say the time taken is equal to, so we'll take this mass, and I'm just going to say the total mass, and we'll use the calculator answer, divided by 35,000. Okay, so I'm taking this value in my calculator and dividing it by 35,000. Let's see, divided by 35,000. And we have, let's see, so this is equal to 1.632 and so on and so forth hours. Okay, but is this 1 hour and 63 minutes? No, it is not. It is 1 hour and a fraction of an hour. Okay, so this 0.632, that's in terms of a single hour. Okay, so it's a fraction out of 100 hour, well, a fraction out of 100 of an hour, if that makes sense. Okay, so to rewrite this, I'm going to say that this is actually equal to 1 hour, okay, and 0.632 and so on hours. Okay, so we need to convert this to minutes. So how do we do that? We just multiply by 60 minutes. Okay, so this will give me 1 hour and let's see in our calculators. So just a quick trick is we can actually take that previous answer and subtract 1 so that we have 0.6324 and so on and so forth, and then multiply that by 60. So this is 37.9458 minutes, okay? But they just want the minutes, so I'm going to round to the nearest minute. So this is technically speaking 38 minutes. So it's 1 hour and 38 minutes, okay? Cool stuff. Let me just move this up a little bit. And that's it for this question. Okay, so there are quite a few questions, especially also with speed and time, where we have to convert hours, which are just given in terms of decimals, into hours and minutes or maybe seconds. So just be careful with this and remember that this is not 63 minutes. Okay, cool stuff. Moving on to the next question. And this is also a very nice one. Okay, so let's see. A and B are points on a circle with a center O, radius r centimeters. Okay, so we have a radius here of r and another radius here, r centimeters. Great. We don't know what AB is. Cool. And the area of the shaded segment is 65 centimeters squared. Okay, so the area of this little shaded segment is 65 centimeters squared. And we need to calculate the value for r. Okay, now where do we even begin with this? Firstly, we know what the area of this little portion is, right? So let's write down how we could define this shaded segment, okay? So we could just take this segment here, okay? So this total portion, and remember, this is just a fraction of a circle with a formula of phi over 360 times pi r squared, right? So if we get that area, so this entire section, and we subtract this triangle OAB, okay, or actually it's ABO. If we subtract that triangle, or the area of that triangle, that gives me the area of the shaded part. Okay, and that's about exactly what we're going to do. So let's say the area of, I'm just going to say shaded, is equal to, okay, so we say that that is actually, let's call this area 1 and area 2. Okay, so the big portion, so this big segment is area 1, and this little triangle is area 2. Okay, great. So that's a starting point. Now we know what the area of this entire segment is. So we just said that that is the angle over 360 times pi r squared. Okay, great. So we have 65. So that area of the shaded portion is equal to 140 divided by 360 times pi r squared. Okay, great. We don't know what the value of r is. We're happy. Now we just need to find an expression that can define the area of this OAB. Okay, so how are we going to find the area of this in terms of the radius? Okay, so we don't know what the length of AB is, but we do know that this is also r. Okay, so that means that we have an included angle and we can actually use the sine rule for area. Okay, so if we do the following, Okay, so let's think about the sine rule for area. Okay, normally it would just be half AB sine C. Okay, and where this sine C is the included angle between the two sides, and this A and B. Okay, so in this case, that's exactly what we're going to do, but these two lengths are just R and R. So that means that this area is a half times R times R times sine 140. Okay, and please stop me in the chat if you're a bit confused right now. Okay, so if you haven't seen the sine rule for area, this is literally what it is. You have a half times the two sides times the angle of the side that is not involved. Okay, and this AB, this opposing 140, that's what we have to use with the sine rule for area. Okay, so now we can take this and we can just plug it into this little equation that we've just constructed. Okay, so this is minus this area. So this is just minus a half R squared sine 140. Okay, and now we just have to solve for R squared. Okay, and in this case, I think it will be the easiest just to factorize this R squared, because this is a variable and we're after it. So I'm going to take it out. That's going to be the easiest. So if we take it out, we factorize R squared, and then what's left is 140, or actually just 14/36, but we'll leave it as is. And this is pi minus a half times sine 140. Okay, and then to solve for R, we're going to divide by this entire term on this side, and we're going to divide by that term on the other side. So we want to get rid of that entire bracket. I'm going to cheat a bit, and I'm going to say copy and paste. So we divide by that. Okay, and we do exactly the same thing on the other side. Divide by that over here. And then we are left with, okay, so we have R squared is equal to this little portion over here. Okay, and now how do we solve for R? We can just put a square root over it. Okay, that's all we have to do, is we can put a square root over it to find R. But now just be careful, R can also be negative, but because this is a length, it cannot have a negative value, okay? So R cannot be negative something because it's a radius, okay? It's a length. Right, so we will put the square root over, not even necessary to put positive and negative, but you can if you want to show the teacher you're smart. Okay, and R is equal to, so I'm putting this directly into my calculator. So let's see what happens. Okay, so I have the square root and then a fraction, 65 divided by, just remember your brackets if you use big numbers like this in your calculator. So 140/360 pi minus a half sine 140, close the bracket again. Okay, and there we have R is equal to 8.496 and so on and so forth. And let's write it to three significant figures. So R is actually equal to 8.50 centimeters. Okay, this was centimeters squared, so this would be centimeters. Okay, and there we have it. Obviously, you could have calculated this. You could have put this directly into your calculator and then only divide by that. But I just like to work with fractions just to be as accurate as possible. All right, but that's it for this question, guys. Let's move on. Let's see if we can work in one more. We have a few minutes left. Okay, let's see. Okay, question 8. Kaito, I think that's pronounced correctly. So we have Kaito runs along a 12-kilometer path at an average speed of X kilometers per hour. Okay, so it's time to incorporate the triangle. You guys remember the triangle? We just have speed is equal to distance over time. Okay, so write down an expression in terms of X for the number of hours he takes. Okay, so we have the distance, we have D, and we have the average speed in terms of X, and we have to write down in terms of X the number of hours. So the number of hours is just T. So T is equal to distance over speed. All right, so this is T is equal to the distance is just 12, and the speed is X. Okay, so in terms of X, my time is equal to 12 divided by X. Okay, so this is a bit of constructing equations. Okay, and then for the second question, Yuki takes 1.5 hours longer to walk along the same path as Kaito. Okay, so the distance is still 12 kilometers. Okay, my time is going to be a bit longer. So this is going to be t plus 1.5. Okay, and she walks at an average speed of x minus 4 kilometers per hour. So this is just going to be my speed. Okay, but this is for Yuki. Now, because they walk along the same path and it's exactly the same distance, we can actually have two equations, and then we can show that it simplifies to this x squared minus 4x minus 32. Okay, so this is my first equation. Let's write down my second one for Yuki. Okay, so let's just call this equation 1. And then for Yuki, we will have t plus 1.5 hours, right? Everything is in terms of hours, so we don't need to worry about a conversion. Okay, so t plus 1.5 is equal to 12 divided by x minus 4. Okay, and this is my second equation. Now, this equation over here, this doesn't have time. Okay, so that's a missing variable in this equation. So that means that if we can substitute this 12 over x into t, we will have an equation that's only in terms of x. Okay, and that's exactly what we want, right? So let's do that. I'm going to substitute 1, well, let's just say sub for substitute, 1 into 2. Okay, so this is just one method. You could also use, well, it's another form of substitution, but we can get both of these equations in terms of t, and then just put those two equations equal to one another. But this is exactly the same thing. Okay, it's essentially the same process. Right, so now this is going to be, in brackets, 12 over x, so that's for t, right? So 12 over x plus 1.5, and this is equal to 12 over x minus 4. Okay, and we have an algebraic fraction, okay, or an equation that is only algebraic fractions. Okay, so how do we deal with this? So firstly, I'm going to find my common denominator, or actually my lowest common denominator, and that is equal to x times x minus 4. Okay, so if you don't know how to deal with algebraic fractions, we find the lowest common denominator just like we would with normal fractions, okay, just to get rid of it. So let's see. What do we have to do to this equation so that every single term has this as a denominator? So that's the first question that you have to ask. And let's just quickly move this over here so that we have a bit of space. Okay, so I have to multiply by x minus 4. Okay, so I'm going to multiply this one by x minus 4 over x minus 4, or you can just multiply by x minus 4 if you understand that the denominators are going to fall away. Okay, if you don't understand that, then multiply by x minus 4 over x minus 4. Right, and this one, we're going to multiply by the entire common denominator. So this is x times x minus 4. Ooh, that's horrible. X times x minus 4 over x times x minus 4. Okay, you guys get what I'm saying there. And over here, we're just going to multiply by x over x. And let me just make a bit of space here because that looks horrible. Okay, let's just redo this one quickly. Sorry, guys, I know that we are going over time. Okay, so let's just multiply by x times x minus 4. Okay, that's slightly better. Right, so now that we know we have the same denominator straight throughout, we can essentially multiply by that denominator and then it will fall away. Okay, or you can write everything out, so we can write it with the same denominator and then you guys will see what's going to happen. So this is 12 times x minus 4. Okay, and everything is going to be of the same denominator. So I'll just go like this. And we have plus 1.5 x times x minus 4. And this is all over x times x minus 4. And this is equal to 12x over that same denominator. So x over x minus 4. Okay, but you guys can see that the whole idea of this is to have the same denominator so that we can cancel it out. Okay, so here These two denominators can cancel out because we can multiply by x times x minus 4. And on this side, multiply by x minus 4, x times x minus 4. And everything cancels out nicely. So what we have left is 12 times x minus 4 plus, and I'm simplifying this, so I'm multiplying this 1.5x into there. So we have 1.5x squared. And what is 1.5 times minus 4? That's just going to be 6. So a negative 6x is equal to 12x. Okay, let's simplify a bit further. This is actually 12x minus 48 plus 1.5x squared. And we could have actually divided by the 1.5 earlier, but it's fine. We simplified it. And minus 6x is equal to 12x. Okay, these two 12x's can cancel out because they are on either side of the equation. And if we reshuffle this a little bit, we have 1.5x squared minus 6x minus 48 is equal to 0. Okay, but this doesn't have a coefficient, or the coefficient is 1. So we have to divide by 1.5 straight through. Okay, so we'll just say that we are dividing by 1.5 straight through. And let's see, that will give us x squared, and then 6 divided by 1.5. We know that that's 4 because earlier we multiplied by 1.5 to get 6. Right, so there's this minus 4x, and 48 divided by 3 over 2, which is 1.5. Let's see. So 48 divided by 1.5, that will give me, oh, let's see, calculator, 32. Okay, great. So everything is correct. We have this equation. All right, and then for the next part of the question, we have to solve. Okay, we have to solve this quadratic equation by factorizing. Okay, I'll just reorder this a bit and make it neat for the notes. But all right, I'm going to do this next question. So solving this equation by factorization, we can continue with that next week. All right, guys, thank you very much for joining, and see you in the next lesson.